Hi, in this video we're gonna to do the partial fraction decomposition of this fraction. By the way, notice that the denominator degree is greater than the numerator degree. The polynomial of the denominator has two linear factors. So this polynomial has two roots. -2 is a sample root with multiplicity 1 and 2 is a root with multiplicity 2. So the sample root gives one fraction and the root with multiplicity 2 gives two fractions. So the partial fraction decomposition is a over x plus 2 plus b over x minus 2 on the power of 1 plus c over x minus 2 on the power of 2. So here, because 2 is a root with multiplicity 2, we have here two fractions with x minus 2. So our challenge is to find the constant a, b, and c. Our job is to find the constant a, b, and c. So we have three unknowns a, b, and c. So how many equations do we need? We need three equations in system to solve. I will give the simplest method. So I begin by a, then c, and the last I will find b by two methods. We start by the constant a. We focus on the constant a. By what factor do we multiply the fraction to eliminate the denominator to disappear the polynomial below the constant a? So we will multiply f of x by x plus 2. So in the left side, here when we multiply by x plus 2, so we simplify by x plus 2, so we get this fraction. For this, also we simplify by x plus 2, so we get a plus this fraction times x plus 2 plus this fraction times x plus 2. So here we factorize by x plus 2. So this equality is true for any real x different from 2 because we can't divide by 0. Then what is the best value of x that gives a? So take this expression 0, so we take x equals minus 2. So a equals x plus 2 times f of x, and we take x negative 2. So this is equal to this expression when x equals negative 2, that gives negative 16 over 16, that gives a equals negative 1. Now we will look for c. By what factor do you multiply the fraction to eliminate the denominator to disappear the polynomial below c? So here we multiply f of x by x minus 2 squared. For the first fraction, here we simplify by x minus 2 squared. This is equal to this fraction times x minus 2 squared plus, here we simplify by x minus 2, so here we have b times x minus 2 plus, here c, because we simplify by x minus 2 squared. X minus 2 squared over x minus 2 squared is 1, so here we get c. This equality is true for any real x different from negative 2, because we can't divide by 0. Then what is the best value of x to give c? So here when we get x equals 2, so this and this 0, so c equals x minus 2 squared times f of x when x equals 2. So this is gives this fraction, we replace x by 2, that gives 4 over 4 is 1, so c equals 1. We have a is negative 1, c equals 1. Now we look for b. We can find b by two methods. For the first method, so here this equality is true for any real x different from negative 2 and 2, because we can divide by 0. Then here, what is the best value of x that gives b? So we can take, for example, x equals 0. So when we replace x by 0, we get here negative 6 over 8. This is equal negative 1 over 2. Plus b over negative 2 plus 1 over negative 2 squared is 1 over 4. So here we can take b equals 1. This equation gives b equals 1. Now we will find b by second method. So here we will focus on b. We will look for b. So by which factor we multiply this equality to get b here, to eliminate this factor below b. So here we multiply the fraction f of x by x minus 2. On the left hand side, the fraction, here we simplify by x minus 2. So here we get x minus 2. And here we multiply by x minus 2 for the first term on the sum. Here we simplify by x minus 2, so we get b, the constant b, and here we simplify by x minus 2, so we get c over x minus 2 for the third term. This equality is true for all x greater than 2. So we can do the limit as x approaches infinity. So here the limit of this fraction is 0, because the degree here is 1 and the degree of the denominator is 2. So the limit is 0. Here the limit of this fraction is 1, so a times 1 is a. Here b is constant, its limit as x approaches infinity is b. and here c over infinity is 0. We know that a is -1, so b equals 1. So here we find b by the second method. But you can choose the easiest method you like. Let's summarize. Here we have a fraction with two roots. So -1 is with multiplicity 1 is a sample root, and 2 is a root with multiplicity 2. So here the partial fraction decomposition is a over x plus 2, because here -2 is a sample root, and b over x minus 2 plus c over x minus 2 squared, because 2 is a root of the denominator with multiplicity 2. So here we get a by multiplying f of x by x plus 2, and we replace x by -2. So that gives this fraction when take x equals -2, so is -1. For c, we multiply f of x by x minus 2 squared, and we take x equals 2, so this fraction gives c is 1. And we take b equals 1 by two method. So we take x equals 0, and we give a equation that gives b equals 1 for x equals 0, or we multiply by x or x minus 2, and we do the limit as x approaches infinity, and we get b. So here the partial fraction decomposition of our fraction is this sum. In the next video, we will do the partial fraction decomposition of this fraction. So the denominator of this fraction has two factor, a linear factor, x minus 2, so it gives a over x minus 2, and a quadratic factor with discriminant is less than 0, so it gives bx plus c over x squared minus x plus 1. So our challenge is to find a, b, and c. So I advise you to do it. Thank you for watching, and see you next lecture.